Alright, so we're going to do part 2 of our review for our final. And we stopped at find the reference angle for the following. And I would like to go to problem 18 now. So we did 1, now let's do a negative. Remember when you have an angle and it's negative, you should go the other direction, right? So then, take your measurement. Okay, and you go the counter, well you go actually clockwise. So negative 90, negative 180, this would be negative 270. If I want to go to negative 200, I would start here, like always, and go to about here. We don't know exactly, but somewhere there. So that's 270 degrees.
It's 200.
Thank you. Sorry. It's 200 degrees. So if the reference angle, remember, touches the x-axis. So this is the reference angle I'm looking for. So if this is 180 and this is 200, how much is the yellow? 20. 200 minus the 180. Now, guys, just in case, it's multiple choice, in case they give you an option of negative 20, is negative 20 the answer?
Nope.
No, because the reference angles are always positive. Okay. In other words, how far am I from 200? Alright. Let's move to 20. Find an acute angle in standard position and its terminal side, terminal just means it stops, okay, passes through point P. Find the value of the 6 trig functions. Do you remember doing these?
Nope, not
okay. This is an ordered pair, right? So my point is this is x and this is what?
Y.
Y. X and y. And then we drew a triangle from, you can build the unit circle if you want. This one happens to both be negative. So if I'm going to go root 5 negative, then I'm going to go this direction. And then I'm going to go negative 3. So where do I go for that? Down. So my point is here, which makes sense because both are negative. What quadrant are both x and y negative? Quadrant 3. Where do I finish my triangle? By connecting what? Back to the origin. Remember more than anything. There we go. This is a right triangle. And now I'm going to label my sides. This is negative root 5. This is negative 3. Write yourself good notes here, because if you just can put 1 on your note card, you can remember how to do it. What side is missing in this particular problem? What piece? The hypotenuse, right? And it's a right triangle, so we can use Pythagorean theorem. If you have both legs, you add. So to find the missing piece, we're going to take negative root 5, and we're going to put it in parentheses, squared, plus negative 3 squared. Type that in your calculator for me. When you do that, you get 14, right? But we don't actually, we just leave it as the square root of 14. We're going to turn it into a decimal, okay? Do y'all remember doing that? Don't leave it as a decimal. Just write it as the square root of 14. Well, no. This is 5, right? And this is 9. Yeah. You just be sure to put your parentheses.
Yeah.
Okay, come on. So then this is the square root of 14, because this is c squared. If you write yourself a note, c squared equals 14, so c equals the square root of 14, right? In order to try to take really good notes for this one. Now, by now, you guys know SOHCAHTOA pretty well, but sine is opposite over hypotenuse, cosine is adjacent, and tangent is opposite over adjacent. Let's find the answer for sine. So I'm talking about this angle. Sine's opposite over hypotenuse. So the opposite would be negative 3. You can write yourself a little note. O over h. Opposite is negative 3, hypotenuse is root 14. Are we allowed to leave a radical in the denominator? No. So we multiply both by root 14, remember? Like it's like an imaginary 1. So you'll have negative 3 root 14 over 14. Kind of ran out of room, I'm sorry. You try cosine. Try cosine. Okay, adjacent over hypotenuse for this particular one would be negative root 5 over root 14. You're not allowed to have a radical in the denominator, so you multiply both the top and the bottom by root 14. The root 14 times root 14 just drops, giving you 14. And the top 5 times 14 is 70. But remember, it's negative. And it makes sense because cosine is the x value, right? So it's going to be negative. Now, tangent is y divided by x, or you can actually just look at it through here, y over x, okay? Or you can do opposite over adjacent, negative 3 over negative root 5. Well, what are two negatives going to make? Think about it. Tangent in that quadrant down there is actually what? Mm-hmm. So multiply both by root 5, you get 3 root 5 over 5, and it's positive. And if you're not sure, remember that little trick we use to help to know what's positive? All students take calculus, right? So everything is positive in this quadrant. Sine is positive in this quadrant. Tangent here, and cosine here. Does that make sense? Now here's another thing to remember. If sine is negative, what does cosecant have to be? Negative also, okay? If cosine is negative, secant is negative. If tangent is positive, cotangent is positive. Remember, because all you're doing is flipping. So, for example, I'm just thinking, if negative 2 over 1 is negative, then 1 over negative 2 is still going to be negative. Right? The flip doesn't change the sign. All right, now let's look at cosecant. Cosecant is the flip of sine. What are we going to flip? Which is the easiest thing to flip? Do you want to flip the beginning, the first part, or the last part? Yeah, why? Y'all are saying the beginning, you're correct. Why do we want to flip this part? Right, it puts the radical in the numerator, which makes the problem a lot easier. If I flip this one and put the radical in the denominator, I got to do a bunch of work. So I'm going to flip this to do negative root 14 over 3. The answer is still negative, because if sine is negative, cosecant is negative. Now move to secant. Here it doesn't matter, right? So I'm just going to flip the beginning because the numbers will be smaller. Root 14 over root 5. Multiply both by root 5. You get root. Should I flip it? Yeah, that's right. You get 5 over root 70. Negative 70 over root 5. I said it backwards, I'm sorry. Okay, I'll give you a second to flip tangent, to find cotangent. Flip it. Alright, remember, tangent is negative, so cotangent is going to be, tangent's positive, so cotangent is going to be positive. I'm going to flip it. I'm going to flip the first one. So root 5 over 3, which is just stays the same. Alright, let's move down to the bottom, 22 and 23. You guys on your own can fill in 21. Convert to radians. So remember how to convert to radians? Okay, if I want to convert to radians, then I want to get rid of my degree, right? Okay, I got to cancel my degree. So let's write 24 over. So if you want to turn it into radians, radians goes on top. That's your little secret. So how many radians are in a circle? How do you count by radians? Remember we said unit circle? You count by what?
Pi.
So how many pies are in a unit circle?
2 pies.
2 pi. If you're going to convert to radians, radians goes on top. So 2 pi. Out of how many degrees are in a circle? 360. And then you just do the math. Okay, so I'm going to take 24 times 2, which is 48 pi, over 360. Can I reduce it? Yes. So get your calculator out and don't type in the pi. Just reduce the fraction. Just reduce 48 over 360. The way you're going to do that is you're going to take your calculator, turn it on. You're going to take 48 divided by 360, and to reduce it, we hit math, enter. We hit math, enter. So the answer is 2/15. So 2 pi out of 15. In other words, 24 degrees is the same as 2 pi out of 15 radians. Now let's go the other way. Convert 9 pi out of 5 over degrees. There's at least 2 test questions on this, so take good notes on this part too. Convert to degrees. Okay, we wanted to convert to degrees, then what goes on top? Degrees. So 9 pi over 5 times, you're going to put degrees on top. 360 over, how many degrees? 360, and how many radians is that? 2 pi. What happens to the pi's? Hopefully they cancel. I don't want pi, I want degree. I want pi too. That's true. So then the pi's cancel. You're going to do 9 times 360. Thank you. Divided by 10. Cancel. You get 324 degrees. Degrees. Moving right along. Find all 6 trig functions at the given angle. Guys, is 210 on your unit circle? Is 210 on my unit circle?
Yes.
Let's look. Here's my unit circle. You'll see 210 anywhere?
Yes.
Right here. So if I'm telling you to find all 6 trig functions, am I going to need to build a triangle necessarily if it's on the unit circle? No, because all 6 trig functions are asking you to find sine, cosine, tangent, cosecant, secant, cotangent. Look, guys, if you're at 210 degrees, okay, this is cosine, remember? This is sine, and this is tangent. It's already built in. Do y'all remember? Okay, so just look there and fill them in. So the first question asks for sine at 210. So remember, this is the x value, and this is the y value. So sine is the y value, so it's -1/2. That's what makes it so nice. You don't need to write triangle or anything. You already found them. So sine is -1/2. If you think about it, 210 is actually in this quadrant right here. So all students take calculus. What's the only thing that's positive? Tangent. Now let's find cosine at 210. So here's 210. Cosine's which value? The x value. So -√3/2. Right, and now find tangent. It's back. Which one of these is tangent? Way out here, remember? √3/3. And it's the only one that's positive. That's because negative divided by negative is positive. Now then you have to flip them. Cosecant's the reciprocal of sine, so you're just going to flip it. -2/1, or just -2. Same thing. You're going to flip secant, which is -2/√3. Can't leave it like that. Excellent. So multiply both by √3. So 2√3/3, and it's negative. I'll give you a second to flip cotangent. Try it. Flip. Find cotangent. You take 3/√3, multiply them both by √3/3. √3/3, and they cancel. Pretty good? Now later on you can come back and do 120 degrees. Right? 120 degrees is in quadrant 2, so they're right here. let's move on to 26. Okay, so first of all, remember that when there's an inverse, okay, but you have to work on from the inside out. If I just start here, okay, let's just start here. There's no inverse, so there's no restrictions. Remember with -1, in other words, if you're talking about radians, okay, which I'm giving you a radian is the inside value. If you're going to use inside value, you are allowed to go anywhere you want in that unit circle. There's no restrictions. So do me a favor and find 2 pi over 3 in your unit circle. And when you find it, you get to here. Agree? Okay, so I'm here. Well, I was asking for sine at that value. So if you're right here, sine at that value is this spot. Agree? 3 over 2. So what I'm going to do now, okay, is I'm going to cross this off. Now this is my problem. That has a -1 there, which has restrictions. Remember talking about restrictions. And with our restrictions, write this down somewhere really important. If you're talking about restrictions, cosine was allowed in quadrants 1 and 2. Sine is allowed in quadrants 1 and 4. And tangent is 1 and 4. So if you're a restriction, that's the only place you're allowed. So when you're dealing with the -1. So where is sine? Remember this is how I would do it. I would say, where's sine positive? Where's sine allowed? Sine's allowed where? In these 2 quadrants. Which of these 2 is y positive? It's positive up here, correct? So I'm going to look up here somewhere for root 3 over 2. And I want y to be root 3 over 2, so it's here. What do I write? I gave you an outside value. What are you going to give me? And what? Inside. An inside. Okay, if I give you an inside value, if I give you a radian, you give me a point. If I give you a point, you give me a radian. Okay? So the answer then is pi over 3. If you didn't get it, let's keep trying another one. Let's try 28. Here. I want the inverse cosine. Okay, I'm doing an inverse problem. I'm going to start with the restriction. When is x, so in other words, if there's -1, you have to use this chart. When is x positive? X is positive when? Correct. Okay? X is allowed here and here, and positive here. So I'm going to look in quadrant 1 for this. Where do you see it? Where do you see cosine that's root 2 over 2? These are my 3 cosine values, so I'm right here. I gave you an outside value. You're going to write down an inside value. So what are you going to write for that spot? Pi over 4. So this is pi over 4. Now then my question is, what is sine at pi over 4? In other words, what is the y value at pi over 4? You're allowed to go anywhere you want if I'm giving you an inside value. So here's pi over 4. What's the y value at pi over 4? Right? Root 2 over 2. Okay? I'll give you a second to try number 30. Try 30. Okay, this has a restriction, correct? So you're only allowed in these 2 quadrants. When is sine? This gave you a positive. So when is sine positive? It's going to be back up here in quadrant 1 for some reason. They've used a lot of these. So I'm looking for sine to be a positive root 3 over 2. So when is y root 3 over 2 in these 3 spots? It's here. All right, I gave you an outside value, so what are we going to write for that answer? The inside, pi over 3. So you're going to say, okay, pi over 3. Now I'm asking you for the cosecant of pi over 3. Can we look at our unit circle ever and find cosecant? No, so what do we have to actually find? Write yourself a note. You're going to look for, what's the flip of cosecant? Yeah, look for sine at pi over 3 and do what? And then flip the answer. So here's pi over 3. I give you an inside value, you're going to give me an outside. So what's sine? What's the y value? Root 3 over 2. And what do you have to do to root 3 over 2? Right. It's 2 root 3 over 3. So I wrote down this, I flipped it, and then got rid of the radical. This is the hardest part we've done so far. Okay, look at 32. Try it. 32 says sine. Okay, you're allowed anywhere you want. There's no restriction. There's no negative 1 there. So sine of negative pi over 3. What does a negative pi over 3 mean? Go, instead of going up, we go down. So let's find that first. Y, that's sine. Y is sine of negative pi over 3. Okay, to get to pi over 3, I would go up 1, 2, 3 stops. To get to negative pi over 3, we're going to go down 1, 2, 3 stops. So here's the same with that spot right there. I asked you for which value, sine or cosine. It asked for sine. That's the y. So once this spot here, negative root 3 over 2. Okay, then I'm going to say, all right, the inverse, that's where I've got the restrictions. Cosine on the inverse is only allowed in these two quadrants. Well, when is cosine negative? Over here, quadrant 2. So we're looking for a negative cosine of this. Look for a negative cosine. Here's my cosine values, here, here, and here. So I'm in this spot. Right here. I gave you an outside value, what are you going to give me? So 5 pi over 6. If you struggled with that and you know it, put a big star by this section and maybe try to work these in your spare time. Alright, let's move to number 34.
5 over 6 or 5 pi?
I'm sorry, 5 pi over 6. 5 pi over 6. Okay, let's look at